So in contents, textbooks, head first programming, go ahead and download it because it's hard as heck to read, you know, in that little preview window. Or you can just follow along with what I'm typing because I'm going to be changing it and stuff like that anyways. Now this textbook is a good textbook. It teaches you an awful lot, but it kind of throws stuff at you in a strange order. This is like chapter 2 and we're already writing stuff that reads stuff from the internet, you know, rather than going into the basics. So it's a little jumbled in my opinion, which is why we use the How to Think Like a Computer Scientist online text instead. Alrighty, our new gig at Starbuzz Coffee. Starbuzz Coffee has made a name for itself as the fastest growing coffee shop around. The CEO is always on the lookout for ways to boost profits. You can see there's a lot of fluff in it. I had a programmer do some work for me, but they're not answering their phone. They've disappeared. Can you take over? I'll let you have the code they came up with. Alright, so here's what they came up with. Hey, wait a minute. Did they get their... no. About to ask if they got their URL back, but no, that's a different one. So we need these lines of code. So pop open idle. File new. Now, just like we've done the Turtle library in the past, we are going to import a library called URL-lib. URL stands for Universal Resource Locator. It's that HTTP code that you know, you type in up at the top when you're internet browsing. There are other kinds of URLs too. There are FTP codes and just all sorts of different ones. HTTP is the one that we see all the time. So anyways, import URL-lib dot request. So we're going to be using a function inside it called request. So we're just importing that function. Which makes me wonder if we have to type the whole thing in right here, but I'm going to not experiment at this point. Then we do page is equal to, and this is a long one, and I'm going to go back and I'm going to paste that address. URL-lib.request.URL open parentheses, and I know I'm going to paste something in there, so I'm just going to put my in parentheses now and then go back and get the address that I need to paste, which I got to by going to our front page. It says URL for Starbuzz. Click that and then just copy it. Paste it there. But it needs quotes around it. I forgot to put the quotes around it. Alright, I'm going to blow this up a little bit bigger. Blow this up a little bit smaller. After it opens a connection to the web page, we want to read in some data. So text, I'm going to break this up into two things. It shows that just as one line of code, but I don't like it when one line of code does too many things, so I'm going to break it up a little bit. I'm going to say raw is equal to page.read. And then I'm going to say text is equal to raw.decode, and inside the parentheses I'm going to put lowercase letters UTF in quotes, UTF-8. I'm going to do a quick Google of that to remind myself what UTF-8 means. UTF-8 is a character encoding scheme capable of encoding all possible characters defined by Unicode. Alright, we don't really need to get what that is. But as you know, there are more characters in the world than just, the English language. And so to support the vast majority of languages and all their 65,000 different letters, people invented something called Unicode. And the English letters are still stored as the English letters, but you know, Swahili and Russian or whatever are stored somewhat differently. So they get put out on the internet and saved in a different format than what you can read. But then they have to be decoded. The browser handles all that for us. Now just for fun, let's print out the raw text. Print raw. This is what it looks like before it gets decoded. And let's run it. So do a save as, save to your favorite directory. Call it starbuzz. And there it is. Now in this case, since there aren't a lot of, you know, Russian and Swahili characters in there, it just looks like plain English. The only thing that we see that is going to change when we print out the text rather than the raw is maybe this B in the front and this quote in the front. So after you see that, print out the text instead. Replace that word raw with the word text and let's run it. Yeah, it got rid of that B in the quote. Otherwise, it looks about exactly the same. If there is a difference, I'm not spotting it. Okay, so what is this program doing? It's opening that page just like your web browser does. It pulls that text in just like your web browser does. It decodes it just like your web browser does. But then your web browser does one extra thing, which is convert all of these tags that we see. Tags are things inside the greater than less than signs into a graphical representation. Without tags, the only thing that the internet could display would be text. And at one time, that's what the internet did. You know, before the graphical browsers came out, there was a browser called Links, and all it displayed was text and then lists of links that you could choose. You know, same idea. You had an interconnected web of links, but hyperlinks, fancy name for them. But you know, much better to have a graphical browser. So let's confirm that what we see down here is what the source code actually looks like. Any page you're on, you can right-click on it. I want to go back to here. Right-click on it and do View Source, View Page Source of some kind. Depending on which browser it is, it may show it differently. And you'll see all the text that makes up the page. So in HTML, a p tag, I think it means paragraph, it opens some text that's going to be displayed. The strong tag indicates that the thing between the tags will be bold-faced. You can see that there are opening tags, and then there are closed tags. The closed tags have the same word as the opening tag, except they have a slash in front of them to indicate the end. So here's the beginning of a paragraph, here's the end of a paragraph. Here's the beginning of the header, there's the end of the header. If you wanted to, you could save this as a text file, an HTML file, and view it in your browser. You can edit web pages. You know, you could create them just with Notepad. You don't have to have a fancy program. Of course, they're going to be pretty simple if you create them with Notepad. And then there's some other stuff. The HTML tag opens the document. The /HTML tag closes the document. Then there's some header information, and then the header information ends, and then there's the body. The body is what actually gets displayed. Oh, we don't need to see all that really, but I wanted you to get the idea of what we're dealing with. We're seeing this text down here, and we want our program to pull that number out, display that number. Let's go back to the tutorial. Hey, that's not right. I only need to see the current price of coffee beans, not that other stuff. Can you just give me the cost? Well, here's what it looks like. This is the price we need, and we can ignore the rest of the HTML. Now we need to know something about strings. A string is just a list of characters. Whenever we use that input command and we let them type stuff in, it's just a list of characters. Each character can be accessed separately. The first one is called 0. The second one is at index 1. The next one is at index 2. The fourth one is at index 3. And so on. Why did I say the fourth one is at 3? Well, the first one is at 0. The second one is at 1. It's like you had a row of apartments, but the apartments started with 0 instead. That's why I called it homework 0, just to kind of trigger in your brain when we get to this point. At the beginning of every list, the first element is 0. So if we told this program to print out element 0, it would just print out a less than sign. We need to know the address of the dollar sign, what the index value of that dollar sign is. And I'm hoping that they tell us, although last time I looked at this, they gave us a wrong number and we had to find it. So we're going to look scroll, scroll, scroll. In the string, we're going to look at position 234 and see if it's a dollar sign. So go back to our text. Do price equals text, and we want position 234. I'm pretty sure that's not right. We're going to have to play with it and get it. And then print the price. Now that's only one character. That's the character that's at position 234, the 235th character in the string. Alrighty, it found a 5. It did not find a dollar sign. So that's probably that one. I'm going to back it up one and hope that it's a dollar sign. 233. Well, that didn't work. That's because I'm supposed to run the module. There we go. And it found the dollar sign. Very good. So just close your shell, not your program. Start a new shell. Run Python shell, just so that we get a blank page. And we're going to play with the idea of these strings for a little bit. Do this. In, short for name, is equal to, and just put your name in here, or somebody else's name, or whatever you want. N is equal to quote Jeff. Now print out in square braces 0. You don't have to add the word print since we're just in the shell. There. In square brace 0 is J. Now instead of saying square brace every time, I may say subscript, I may say index of, but you'll get used to typing it like that. I'll try to be clear. In subscript 1, in square brace 1, is the E. In square brace 2, what's that going to be? Yeah, it's going to be an F, as will in subscript 3. In subscript 4 is going to be an error. It's past the end of the string. Now you can get a series of characters. This is called a slice, by using a colon to separate two values. So if I do in 0:2, that's going to get J and E. So what is it really doing there? It's starting at position 0 and going up to but not including 2. So since 2 was the F, going up to but not including 2 gave me J and E. However, that's kind of weird to my thinking. The way that I always think about it is what's 2 minus 0? 2. So starting at position 0, give me 2 characters. That's how I think of it. So if I change these to a 1 and a 3, 3 minus 1 is still 2, so it's still going to give me 2 characters. So in 1:3 is the E and the F. Starting at position 1, give me 2 characters. And if I made it 1:4, it'd give me 3 characters, because 4 minus 1 is 3. 1:5 gives me 4 characters, because 5 minus 1 is 4. Let's go back to our code now. So we want this price starting at 233. Now we're going to add a colon. This is the line that we're editing. And And how long is that price? It's a dollar sign, that's one, a number, a period, and two more numbers. We're assuming that the price never gets larger than $9.99. So I'm going to start at 233, and I want 5 characters. So 233 plus 5 is 238. Hopefully that'll print the price out. $5.76. That's cool. The only problem is we don't really need that dollar sign, right? Because that would, if we tried to call a float on it to do some math, that's going to break it. So why don't we change that to a 234.38? And then why don't we turn that into a float? Price equals float price. I should have done that before the printing. I'm going to take that print and move it underneath the float. So I've changed that line. Changed that line. Our big change was to make this 234 to 238. And indeed it worked. It found a price. It said it was $6.92. Very good. But there's a problem with this web page, or with the way that we're doing this. The problem is that we don't know if anybody's ever going to edit this web page. What if the owner of this company decides that they want spaces around the R? Well, they put some spaces there. That means that this is no longer going to be at position 234. What if they could change their company name? What if they make any edits to this thing at all? What if they change the header? We won't even be able to see the difference on this page, but it will change the position of that dollar sign. So what we need is a way of searching through that entire string, get the dollar sign, and return the position of it. Now, there are ways to do that. We could write a loop that would do it. Is character 0 a dollar sign? Nope, keep going. Is character 1 a dollar sign? Nope, keep going. Is character 2 a dollar sign? Yay, it is. You know, exit the loop. But there are functions for doing that. Okay, so on this page of the text, there are functions that you can call on strings. Go back to your Python shell, do n is equal to a name again. And then do n.upper, parentheses, in parentheses. It returned an uppercase version of itself. Do n dot begins with, and then the first letter of your name. Ew, what do you know? Starts with rather than begins with, excuse me. So, n dot starts with J. True. I'm going to pick a character that it doesn't start with. N dot starts with E. False. It does not start with an E. Now let's find the position of the first F. N dot find, and find me an F. -1. Why did it return -1? Because I looked for an uppercase F, and there are no uppercase Fs in here. So I'm going to repeat the same thing. And of course you need to be using letters that are in your name. Lowercase f, and it found it at position 2. which for my name is correct. 0 is J and 1 is E. So F is 2. So we can use this .find to look for the dollar sign. All right, they use too long of a word here. Start underscore of underscore price. I think I'm just going to call it P start is equal to price dot find and look for a dollar sign. And then P end is going to be that plus 5 because the price seems to always be between $1 and $9.99. So P is equal to P start plus 5. So now let's get that price again. Price equals text, starting our slice at P start and ending our slice excuse me, at P end. So P start colon P end. Now we want to turn it into a float. Price is equal to float price. Print that price. I'm leaving the old code there for now just so that to make sure that we get the same answers. But eventually we're probably going to want to delete a lot of this stuff. Or at least comment it out. Alrighty. Float object has no find. Okay, I made a mistake here. Where it says price.find dollar sign, it really should have been text because text is the string that we're searching. So instead of price.find, change that to text.find. Could not convert string to float. Well, we're getting there. We don't want the price to include the dollar sign. So let's actually add one to the price, to the P start. So this line has changed a lot. Double check it and make sure that you've got it exactly how it is. P start equals text.find parentheses quote dollar sign end parentheses plus 1. Let's see if that gets it. It's good. So we're going to have to lower this one by 1. Okay. And then change the next line to P start plus 4 rather than 5. All right, it found the price 2 times using 2 different mechanisms. So if they ever edited the page, the code would still work as long as they preceded the price with a dollar sign. Once you get all that to work, you see these lines, the first printing of the text, that 234 to 238, that first float and that first price. Either delete those or do format comment out region. You know, get rid of those 4 lines somehow. I'm just commenting them out. Because we don't want to print all the text anymore, and we don't want to print the price 2 different ways. I just want the price. There we go. So we have typed in enough that I need to pause this and make sure everybody's got it up and running. I forgot to say I only need to know the price when it's lower than 474. I don't want it to bug me when it isn't. So we need a loop. We need a price while price is less than 474. However, that's called hard coding a number. That's putting a number into the program. That might change. So I'm not liking using that number in a while loop. So why don't we just go up to the very top and add a little bit of code that asks for that price. Target is equal to input what price, question mark, end quote. And then turn that into a float. Target is equal to float target. Then we're going to put a while loop. We're going to put a while loop that starts here. You don't have to put these comments. And ends there. So I just added these 2 lines. I'll comment them. So we want it to loop as long as the price is greater than 474. So we're going to set a price that's arbitrarily high. What do I mean? We want it to go into this code while price is greater than 474. So I want a number that's always greater than 474. In fact, I want it to always be larger than everything. So I'm going to do price. Guess I'll start typing here. No, I'm going to still put this above the line. Price is equal to 9,999. There we go. No coffee will ever cost that much. I hope. At least not this year. Now we need a while, and we need everything that we've typed so far indented. So while price is greater than our target, colon, we need to tab all of this stuff over. And there's a way you could do it all at once, but I just did each line individually. There were only 5 lines of code, so it didn't take that long. And then after our while loop, once it's finally done all this, let's print buy it now. So if you get all that typed in correctly, I'm going to delete these commented outlines. There we go. So that was a new line. Take out a couple of these comments. There we go. It asked me what price. And the book said 474 is our target price. Now honestly, it seems to me, well, what do you know? I should have indented more code than what I had. That's not too cool. So you see this page is equal to, and raw is equal to, and text is equal to. That needs to be inside our while loop too. So grab those 3 lines, cut them, and put them underneath the word while. Why? Because we need to reread the page every iteration through the loop. Otherwise, it's just finding the same price. Be like opening a box just once, when instead you want to open it every time you want to look inside it. So I'm going to cut those 3 lines. The page equals, raw equals, and text equals. I'm going to paste them after the while statement, and I need to tab them over. All right, 474, that was his target price. To my knowledge, it never hits 474, so that's too low of a number. And there's a second problem with this code. Y'all may have heard of a denial of service attack, which is when you get a whole bunch of computers to access the same server as fast as possible and you try to overwhelm it with too many hits. So when y'all are all running this, we have 20 people issuing about 20 accesses per second on the server. Now I'm sure that this one can hold it, can meet that, but it's bad web programming. We should not be hitting the page this often. So I'm going to close the window so it stops running. So after we start running our program from the Department of Webland Security, to whom it may concern, a recent investigation into apparent distributed denial of service attack on the BeansRS website reveals that it comes from your computer. Okay, so we're going to fix it so that it doesn't do that over and over. And in real life, would you get a letter like this? No, but you can actually get in trouble by participating in denial of service attacks. So if you're a 4chan user and you feel like, you know, because somebody else said, download this program, the Ion Cannon program, and run it against Microsoft or whatever, you can actually get into some federal trouble for doing that, so don't. We need to put some code in there that will cause the program to sleep. Sleep is what they call it, for a few seconds, so it pauses between requests. That's going to involve probably another library that we need to bring in. There's a time library that's got time.clock, which will print us the current time in seconds, time.daylight, whether daylight savings is in occurrence or not, local time, sleep, that's the one we want. So we need to add the statement import time. Now I wish I could import time, you know, just whenever I needed it, but here we go. Import time. Add that line. And then we need to sleep. But we really only want to sleep if the price isn't right. So come down to this last thing, the last thing in your while loop, above that print price part, and do if price is greater than target, colon, tab over, time.sleep. Now he says sleep for 900 seconds. That's 15 minutes. I don't feel like doing that. Let's sleep for 5 seconds. That's still too aggressive, really, but, you know, for something that's going to be running background in the server. So we need to add these two lines to the bottom of our program. I'm just going to comment them with sleep. And we're probably going to get rid of the rest of these comments. We know what we've changed. There we go. Run it again, but give it a higher number than 474. As far as I know, it never reaches 474, so what price? I don't know, 525. So it's waiting 5 seconds per try. If I was really impatient for this to run, I would make it, 1 second. But it found it. It only took 3 tries. I'm amazed that it found it that quickly. So just for grins, I'm going to run it with 474 again while I wander around and help y'all. 474. Got to add an import statement. price. Price equals. Get rid of one of those. Yeah, that'll fix it. And you can delete that other print if we just add one. We all good back here?
How much coffee beans?
3 beans. I don't know.
This isn't giving me much information.
Yeah. Yes, sir.
One coffee bean.
Let's see what line that's on. You have spell target second type. Oops, sorry. All right, that's really enough to do with the program. The textbook shows something that's really cool if it worked, which is to send a tweet when it hits that price. And yeah, at one time you could write programs in Python that would do tweets, post to Twitter. Twitter a long time ago forbade programs from using that API because you could write programs that would just spam Twitter endlessly, you know, with thousands of posts. So you can't do that anymore. So this is really enough for this particular program. Well, let's check the text. I swear it never reaches 474, so I don't know what the deal is, why they chose that. So things we need to know. What is a string? It's a sequence of characters. Each character in that string is referenced by an index number. Index values are offsets that start from 0. So it starts at 0 and then it goes out. Methods. Methods are things that are attached to data, like the string class or the time class. They provide variables with built-in functionality. Like if we want to find a position in a string, we call .find on that string. If we want to turn it uppercase, we call .upper on that string. So we've already been using float. We know how to use s.upper now, although we didn't actually use it in the assignment. We demoed it in the shell. We know what the time library does now. Okay, the next thing that he does here in this text is to take this stuff and to put it in a function. I don't think we need to do that. So, we're going to do something instead. Close this program or start a new one. Do a file new, do a save as, call it lists. And we're not going to do anything fancy, so we don't need to put any imports in here. Now let's define a list of movies. No, let's do books. The greatest books in literature. Tom Sawyer. But that's just one book. Instead, let's make books a list. So to do a list, we have to put square brackets around it. So instead, I want to put Tom Sawyer, and it needs to be in quotes, my mistake. But I want more than one book in my list of world's greatest books. So what's another one? Twilight. There we go. What's another? Where's Waldo? Now let's print that list of books. All right, thank you. I got at least one laugh out of that. I appreciate that. So it printed our list of books, but that's not a very nice format, you know. We might want to print the books one per line, and we could do that with a loop. We know we can do it with a loop because we can access each element of that list the same way we were doing with that string, with index numbers. So let's do print, parentheses, books, subscript 1. No, 0, because 0 is the first book. And then print, parentheses, books, subscript 1. Print, subscript 2. All right, that ought to print each one of those items one per line. So far, so good. But it'd be better to print it out as a loop. Our list may not only be 3 items long. Let's go add another book up here. What's another book? Lord of the Rings, yeah. Fellowship of the Ring. I'm just going to put Fellowship. There we go. Now when I run my code, it's going to leave that one off because I have this, coded to only do the first 3 books. And realistically, a list could be hundreds of items long or thousands of items long, so we would not want to do that. Instead, we want to make it a loop. I'm going to comment those 3 lines out. And I'm going to declare a variable called I and set it equal to 0. And we want a loop while I is less than the length, len, parentheses, books. We want to print that book out, so print books subscript I. Then we better add 1 to I, so I plus equals 1. That will print out all 4 of those books. Let's add some more books to our list. Books plus equals, or just books equals, books plus. Let's make a new list. Just tack on 4 more books, whatever you feel like. Jaws, Curious George. Good Night Moon. 3 bedtime stories for your kids. And we may as well have put that above the while statement so it would print them all out. So I'm going to do that. I'm going to cut something and paste it elsewhere so that our while list follows that addition, that appending, concatenation of the lists. So something to notice about lists is that if I do something like a name is equal to Jeff, I can only access elements 0 through 3. 0 is the J, 1's the E, 2's the F, 3's the F. I can't do 4. If I print out len name, it's going to print 4. But I can only access elements 0 through 3 because it's 0-based indexing, not 1. So I want to make a list that's just the first 4 elements of this list. I'm going to call this S books for sublist or something like that. Is equal to books let's say I want to skip the first one. I'm going to start it at 1. And I want the list to be 4 books long, so I'm going to go out to 5. 5 minus 1 is 4. And then just print that out. Print S book. So that second list should only be 4 books long. So let's make 2 more words, 2 more. F book for first book. And what's the index number of the first book? Did I hear somebody say it? 0. What about the last book? Well, we could count it out. It's how many books long is it right now? 1, 2, 3, 4, 5, 6, 7. Really? 1, 2, 3, 4, 5, 6, 7. So what's the index of the last book? 6. Right. So let's print, quote, first book equals, comma, F book. Print last book equals, colon, comma, last book. Seems to work. There's kind of a problem with this code. This 6 is a bit arbitrary. If the list ever grew in length, that 6 would no longer work. If the list was fewer than 7 books, it would crash. 2 ways to handle that. One is that we could get the length of the book list and subtract 1 from it. Since length would return 7, then length of books minus 1 is 6. That would work. Or Python is weird, and it's the only language that I know that does this. But if you use a negative index number, it starts counting from the other side. Goodnight Moon is index -1. Curious George is index -2. Jaws is index number 3, -3. So I'm going to change that 6 to a -1. I just changed that line. Alrighty, that seems to work. I think on that line that says print S book, I'm going to add a string in front of it. So it's going to say print sublist equals, just because it's a smaller list of the books. That way our print statements have something in front of them so that we know what we're seeing. And similarly, this print right here, so I just modified that one. Let's modify this print as well to put I, comma in front of the book list. So I, comma. Now as we print stuff out, there's more information on what it says. It's got the books 0, 1, 2, 3, 4, 5, 6. It shows the sublist, the first book, and the last book. All right, that is about enough. I'm going to kind of tuck this to the side and go get the homework assignment based on this. That's not the right one. Get lost. Okay, so here's our homework. It's also about string lists. Make a program called movies.py. What the program needs to do is create a list called movies, add 10 movies to the list, display the first and the last movie, display all the movies with a while loop, and then using slices, slices is when you use the colon, get a list named middle that contains everything but the first and the last movies. Then print that list. So it's actually pretty similar to this. So let's make a Dropbox for this in class. So the Dropbox is Dropbox in for the in class. Go ahead and put in the starbuzz and the lists files, those two scripts. And the homework that I just discussed is in homework box 10. It'll be due a week from today, Sunday night. All right. That is all. Any questions? I see a question.